Good day, grade 12 learners and teachers. Welcome to today's subject lesson, which is mathematics. My name is Sibusiso Shongwe, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Right, welcome to the new term, which is the last term of the year where we make sure that we consolidate everything and we make sure that you know everything there is to know about the papers that are going to be written, because they determine your future. So today what we'll just be looking at is the review of the preparatory exam that you wrote. We are just going to look at selected questions in paper 1. We're not going to do all the questions. We'll just do selected questions just as a review of what actually transpired, or how you were supposed to answer those questions that were actually asked in your preparatory examination. It is very, very important that you review your prelim paper and you check the mistakes that you've made, so that you can be able to improve your marks when it goes to the final examination. Remember, now you are done with the syllabus, you are done with everything there is, so it's important that you go back to those topics that were giving you problems, look at them, try to make sure that you ask as many questions as you can from your teachers, and make sure that the targets that you've set out, you are able to reach them. It is doable. Our subject is possible, but you guys need to work very, very hard. This is the last lap, and we believe in you, and we believe in your ability to can pass the subject. Right. To start off with, obviously we're just going to review our targets. We look at the targets that we have set, and we check the minimum target that you need just to get that minimum pass in mathematics paper 1. Remember, it's important to set your own targets and be able to make sure that you reach those targets. Right. When we look at the distribution, you can see that it's algebra, patterns and sequences, functions, finance, differential calculus, as well as probability. And now you can see the weighting as well as the range. You can see in algebra it's between 22 to 28 marks, and for you to just get a minimum pass, you need 15 marks for algebra, which means that as and when you prepare for your final exam, you need to ensure that you are getting 15 or more on algebra, because that should be a bare minimum marks that you get in order to pass the paper. Patterns and sequences, you just need a bare minimum of 12, and the topic will range between 22 to 28 marks. That's very important. It's important for you to set those targets and be able to reach those targets. When we look at functions and graphs, it's 32 to 38 marks, and your minimum target should be 15 marks there. Look at the questions that are asked. Try to check how you can get these 15 marks. There are questions that would be asked on sketching of functions. You should be able to sketch all those algebraic functions so that you get those marks, the sketching marks. And then with finance, it's between 12 to 18 marks, and the minimum required is just 5. But with finance, you can always get more marks, because you get marks for using those compounding periods correctly. You get marks for converting that percentage to a fractional interest rate. So it's very, very important that you understand those basics: how to use the future value annuity, how to use the present value annuity, how to use decay and depreciation. Very, very important. Differential calculus, obviously it's between 32 to 38 marks. You just need a minimum of 10. Here you can get way more than 10 marks, because your 5 marks would always come from using first principles to find the derivative. So you get the 5 marks from there. And then there are also questions on rules of differentiation. You can get a lot of marks from that as well, which means that these 10 marks should just be a bare minimum. You can always get more. And then with probability and counting, it's between 12 to 18. You just need a minimum of 10 marks there. And in total, you'd be getting 67 out of 150, and you only need 45 marks for you to get a minimum pass. That is a minimum target. Obviously, for a bachelor, you'd be targeting those marks there that I've written in green. So it's very, very important that as an individual, you set those targets for yourself, and then you try to make sure that you practice topic by topic to ensure that you reach the target in each and every topic that would be examined there. Right. Obviously, your question paper would always have the information sheet. It's important that it is used. You at times, you guys do not use the formula sheet the way it should be used. That is why at times you get that you lose a lot of marks on formulas that have been provided to you. So make sure that you familiarize yourself with the use of a formula sheet. The use of a formula sheet, very, very important. I'll make an example. Most of you would lose a lot of marks on this condition for convergence because you do not look at the formula sheet and copy the condition from the formula sheet. You just do something else there, and you start losing a lot of marks. So that's very, very important. So you can see that in the first page, these are normally formulas that are used in paper 1. You can see it starts with algebra, and then the second line there would be your finance, and then you see that now you have those number patterns, and then from there it's annuities. You can see also the first principles there, and then the information sheet continued. You can see that now you have formulas that are mostly used in paper 2, but it does not mean that they cannot be used in paper 1. All these formulas that are here that I've just highlighted there, these formulas can also work in paper 1. Remember, they can also ask about inclination in paper 1 in functions. They can ask about inclination of a line segment. It does not mean that inclination is only limited to paper 2. Any line segment can have an angle of inclination, and in linear functions you get inclination. So it is important that you also keep in mind that paper 1 topics can be integrated within paper 2, or paper 2 topics can be integrated within paper 1. Right, as we move right along, it's the information sheet continued. You can see this sheet there, this slide here is just the formulas that are used for trigonometry. Very, very important formulas as well. Right, now we start looking at our Gauteng paper that you guys just wrote. We are going to start by looking at paper 1, question 2. Remember, I indicated that it's not all the questions that would be done. It's only selected questions because of the time frames that we have. Right. If you look at question 2 there, they said consider an arithmetic sequence 1 minus p, 2p minus 3, and p plus 5. You are told here that the sequence is arithmetic. That's very, very important, which means you are not going to check whether it's arithmetic, geometric, combined, or whether it is quadratic. You're not going to check all of that. You're just going to go straight to these formulas for arithmetic patterns. These are linear patterns. So if you are told it's arithmetic, so you are definitely sure. You don't need to go and test it. Now, calculate the value of p. So the first thing that they wanted from you was to calculate the value of p. And you see that you've been given T1, T2, and T3, and you need an equation for you to be able to calculate the value of p. And the simplest way to generate that equation is to use the formula for the common difference of this. You know that if you want to work out the common difference, that is 2.1.1, when you want to work out the common difference, you would use your T2 minus T1, which is equals to T3 minus T2. That would be your common difference. So this would therefore give you the equation that you need for you to be able to calculate the value of p. So whenever you are given a sequence of unknowns, then you ensure that if the sequence is known, whether it's arithmetic or geometric, then you're going to generate that equation by using the formula for the common difference if it's arithmetic, or common ratio if it's geometric. Right now, if you look at this, you can see that T2 is 2p minus 3. Subtract T1 is 1 minus p, and then you have that T3, which is p plus 5, minus 2p minus 3, like that. Now, what is very, very important here also is the use of brackets, because you are dealing with binomials. Every time when you add or you subtract a binomial, it's important to use those brackets. Even when you multiply by that binomial, it's important to use the brackets so that you are always safe. So you can see that when I subtracted T1, I used the brackets there to ensure that I trap everything inside the brackets. Also, when I subtracted T2 from T3, I did the same thing. Now, if you open these brackets using distributive law, you get that this is minus 1 plus p, this is p plus 5, minus 2p plus 3. Like that. Now, when you simplify this, you get that this is 3p minus 4 is equals to minus p plus 8. Like that. Now, obviously, we are trying to simplify and solve for p, so we're going to then transpose that. We get this is 4p, because when you take minus p to the left hand side, or you use the additive inverse there, then you're going to get that this is 4p, and then this would be 8 plus 4, which is 12, which means that your 4p is 12, which means that p is equals to 3. Now you've worked out the value of p there. You got that p is equals to 3. Now that you've worked out the value of p, which means that you can then write your sequence in terms of numbers, where you eliminate the parameter p, because you know what p is. Now, the next question says, write down the first term. Write down the first term, which means you are looking for T1. You know what T1 is in terms of p. T1 is 1 minus p in terms of p. Now you know what p is, so this would be 1 minus 3, which would give you minus 2. So already now you've worked out T1. You got that p is 3, therefore T1 here becomes negative 2, like that. T1 becomes negative 2. Right, let's move on. Write down the value of the common difference. Write down the value of the common difference. Obviously, if you look at this, you can see that you can then generate a sequence here, or you can take any of these that you've worked out, because they represent the common difference, so that you get the value of d. Alternatively, what you can do is you can substitute the value of p for T1. This would be 1 minus, remember we got p on the previous slide here, we got that p is equals to 3, so we can use that. This is 1 minus 3 comma 2 into 3 minus 3 comma you have now 3 plus 5. So this would be negative 2. This would be 6 minus 3, that would be 3, and then 3 plus 5, that would be 8. So this would be your sequence now in terms of numbers, where you've eliminated the parameter p. So you can work out d. We know that d would be T2 minus T1, like that, which means that it would be 3 minus negative 2, which means that d would be equals to 5. So your common difference in this case will then be equals to 5. Right, now the next question says, explain why none of these numbers Explain why none of the numbers in this arithmetic sequence are perfect squares. Explain why none of these numbers are perfect squares. This question is pitched a bit up. It's a higher order question which requires reasoning, but it's not that deep. When you understand your perfect squares, then you can be able to respond to this. If we look at the pattern, minus 2, 3, and 8. So the question is, explain why none of these numbers are perfect squares. Let us try to extend it just a bit. Remember, the common difference is 5, which means that we can add 5 to get to the next term, which means that this term would be 13, the next term would be 18, the next term would be, as you add 5, the next term would be 23, and so on. Now, we want to explain why generally this sequence will not have any perfect squares. So let us start by zooming into T1. If you check T1 is negative. T1 is negative. So because T1 is equals to negative 2, T1 is negative, which means that T1 cannot be a perfect square. T1 cannot be a perfect square because a perfect square can never be negative. Perfect square represents positive integers. So this cannot be a perfect square because it is negative. Now let us investigate the remaining terms. Now if you check the remaining terms, starting with T2, it ends with a 3. T3 ends with a 8. This one, T4 ends with a 3, ends with a 8, ends with a 3. So you can see the pattern that is generated here are numbers that end on, they end with 3 or with an 8. So it's very, very important that we zoom into those numbers now. If we check all the remaining terms, end with 3 or 8. They end with 3 or 8. There is no perfect square that ends with 3 or an 8. All our perfect squares would end either with 0, they would end with 1, they would end with 2, they would end with 4. So we don't have any perfect square that ends with a 3 or an 8. So all the remaining terms end with a 3 or an 8. So they cannot be perfect squares. They can never be perfect squares. That's how you can attempt this question. You broke it up into 2. You looked at the first term, which was negative. It can never be a perfect square. And then you check the remaining terms. You see that they end with a 3 or with an 8, which means that they can never be perfect squares as well. Alternatively, what you can do, allow me to just use the space here. Alternatively, what you can do is you can generate the nth term of this sequence. Now, if you look at this, the nth term is generated using a plus n minus 1d, which means that to generate the nth term, a is minus 2 plus n minus 1, d is 5. This would simplify to, it would simplify to 5n minus 7. It will simplify to 5n minus 7. This is the nth term. Now, from this nth term, you can see that whatever n becomes, whatever n value you use there, when you subtract 7 from that, you can never get a perfect square. So Tn can never be a perfect square for n an element of natural numbers. If you use any natural numbers there, you can never get a perfect square if you you use this formula there. Whatever the value of n is, can never generate a perfect square. Right, we move on. Now, the sequence of numbers forms a quadratic sequence. It's very, very important also here. You are told that the sequence is quadratic. So because you are told that it's quadratic, you are definitely sure that the second differences of this particular sequence is constant. So now, remember this, a quadratic sequence is a parabolic sequence. Remember our arithmetic pattern or sequence is a linear pattern. It represents a straight line, and this one represents, a quadratic one represents a parabolic function or a second degree function or a quadratic function. Now, with our geometric, it represents an exponential function. So there is a link between these patterns as well as your functions. There is a link between the two. So you need not to isolate your workings with linear patterns, quadratic patterns, and so on from functions. You should always make sure you marry them together because they represent the same thing. This is just an algebraic way of working these functions out. So it's very, very important that at the back of your mind you know that you are actually operating with functions when you work with your patterns there. Now, the first differences of the above sequences also forms the sequence. Determine an expression for the general term of the first differences. Here they are clear that they want you to zoom into first differences. So what is important is that you will take then your sequence, from your sequence minus 3, minus 2, minus 3, minus 6, minus 11. You generate the first differences. Minus 3 minus 2 minus 3. This would give you 1. Minus 3 minus 2. Minus 3 minus negative 2. This should give you negative 1. Negative 6 subtract negative 3. This should give you negative 3. Negative 11 subtract negative 6. This should give you negative 5. So that is how we try to actually find the first differences. So you are told here the first differences also forms a sequence. So we are going to actually zoom into the first differences and analyze them, because you are told that these first differences they represent or they form another sequence. So what we're going to do is we try to find out what that sequence would be. Negative 1 subtract 1, this gives you negative 2. Negative 3 subtract negative 1, this gives you negative 2. Negative 5 subtract negative 3, this should give you negative 2. So you can see that the second differences are constant, which means that the first differences represent, these first differences represent a linear or an arithmetic sequence. They represent a linear or an arithmetic sequence. Now, from here, we want to find the general term, because that's what the question asks of us. It says, find the general term of the first differences. So we're going to be using Tn is a plus n minus 1d. That's how we find first differences of an arithmetic sequence. I'm going to continue with it here. So obviously, we're going to look at this as our T1, this as our T2, this as our T3, this as our T4 of a linear pattern that represents the first differences of the original quadratic pattern. So you see that A is equals to 1, so Tn would be 1 plus n minus 1, and D is equals to negative 2. So now from here, if you can actually distribute, you get that this is 1 minus 2n plus 2. So if you simplify this further, you get that this is minus 2n plus 3. That's negative 2n plus 3. So that represents now, it represents the general term for the first differences of this sequence. Now the next question asks, calculate the first difference between the 35th and the 36th term of the quadratic sequence. That's very, very important that you know, or they tell you which sequence they are referring to. In this case, they are referring to the original quadratic pattern, and they are talking about the 35th to 36th term. We want to know the first differences. Now, if you check here, the first term of an arithmetic sequence is the difference between T1 and T2 of a quadratic. And the second term of a linear pattern is the difference between T3 and T2 of the quadratic pattern. So if they are looking for the difference between the 35th and the 36th term, then they are trying to tell you that they are looking for T35 of the linear. To T35 of the linear, because 35th and 36th term represents the 35th term of the linear pattern. So this would be T35 is equals to, we already have the general one, so we would use 2 into 35 plus 3. And then if you simplify that using your calculator, you get that this is negative 2 into 35 plus 3. Obviously, this would give you negative 67, because minus 2 times 35, that's negative 70 plus 3, that is negative 67. That would represent your T35 in this case. Right, we move on. Right, determine the expression for the nth term of this quadratic pattern. We want the expression for the nth term. So we want the general term of this quadratic pattern. So which means that we need to go back to our pattern minus 3 minus 2 minus 3 minus 6 minus 11. Obviously, we've generated here the differences. We've generated them in the previous slide. We got that this minus, it's 1 minus 1 minus 3 minus 5. It's 1 minus 1 minus 3 minus 5. And then this is negative 2, negative 2, negative 2, like that. So if we want to generate the nth term, there are many methods that we can actually use that you were taught. You stick to the method that works best for you. I would use this, the 2a is given by that, and then I would use this as the 3a plus b, and then I'll use this as a plus b plus c, and then from there, if I solve, I'll be able to find a, b, and c. So if my 2a is negative 2, then a becomes negative 1. A becomes negative 1. So my 3a plus b, I already have a is negative 1 plus b is 1, which means that my b will then be equals to 4. B should be equals to 4, like that. And then obviously I have a plus b plus c minus 1 plus 4 plus c is equals to negative 3, like that. So my c will then be equals to negative 1 plus 4, that's positive 3. Transpose that, you get negative 6. So you have now your A, your B, and your C, which means that you can then write your nth term. Your nth term would then become minus n squared plus 4n minus 6. So that would be your nth term of this quadratic pattern, minus n squared plus 4n plus 6. Hopefully all of you are able to do this, because remember, quadratic patterns are done in grade 11. Right, the next question here would be 2.2.4. Show that the sequence of numbers will never contain a positive term. Remember, learners, you should not shy away from answering these questions. These are pitched a bit up. It's higher cognitive levels, but it's not so complex that you cannot respond to it. Just check the question and make sure that you understand what is it that is expected from you, because once we solve these questions with you, you see that they are solvable, but when it's exam time, then you struggle solving them, which means that you need to try and do more of these non-routine questions, because these are not the routine procedure questions that you normally deal with. So these are non-routine questions. They demand you to think a bit deeper. You have the ability to do so. You have the ability and capability to do so. Right, let's check what this question demands of us. Show that the sequence of numbers will never contain a positive term. So you need to show that there would never be a positive term. An approach that one can take here is find the maximum. Remember, this is a quadratic function. This, you can see that a is negative. A is negative from this parabola, and if a is negative, you know that this parabola would be concave downwards. So we normally say it's a set function or it's faced downwards. So you know that it will have a maximum value. If we can find this maximum value, if we can work out the max value of this, then it can tell us something about this pattern. Because remember, once you've worked out the max value of the concave down function, once you've worked out the ceiling, the max value, it means there is no term that is going to be bigger than that max value. There is no term that is going to be bigger than the value that you obtained as a max value, which means that you can now be able to draw some conclusions from that. So that is the approach that we are going to actually adopt here. Remember, to find those max value, you can use completion of the square, because this is quadratic. You can use completion of the square, number one. You can use calculus, that's number two. You can also use minus b over 2a to find the axis of symmetry, then back substitute that axis of symmetry to can therefore find the max value. So I can use here that since I have that Tn is equals to minus n squared plus 4n minus 6, I see that a is negative 1, b is 4, C is negative 6. So I can use n is equals to minus b over 2a. That is the equation for the axis of symmetry. Remember, you can also differentiate and set the derivative to be 0, because you are finding the maximum. You are finding the maximum. So you can differentiate and set the derivative to be 0 and solve for n. Or you can use n is minus b over 2a, because this is quadratic. So minus b, that would be minus 4 over 2 into negative 1. This gives you 2. So n is equals to 2. So if you go back and substitute, you can find max Tn by back substituting. It would be negative into 2 squared plus 4 into 2 minus 6. So you get that this is 4 plus 8 and negative 4 plus 8 minus 6. So this, you can see that it gives you negative 2. So max Tn, allow me to continue here. Max Tn, the maximum value here is Tn max is equals to negative 2. So this tells you there will never be a term in this sequence that is bigger than negative 2, because we found the max value. So there won't be any term that is bigger than negative 2. What does that mean? The sequence has a max term equal to negative 2. Therefore, there would never be a positive term in this sequence. because the biggest term is -2. So that's how you were actually supposed to approach this question. Remember, you can use your calculus, you can also use your completion of the square. Right, we move on. We now move on to your question 3 on the prep exam. We are quickly going to look at your question 3. Let me go back like that. So our question 3 here, we are given the sum formula and they want T6. Remember now, it's very, very important that you are able to analyze these sum formulas. You are no longer given the general term, but you are given the sum. And whenever you are given the sum, you can be able to determine the term, any of the terms in this particular sequence. Say for an example, you have 2 plus 3 or plus 5 plus 8 plus 11. So these are your terms like that. It's 2 plus 5. They represent a series. Now, if you check the sum of the first two terms, if you add T1 and T2, remember you are going to get S2. Your S2 is equals to 7. If you check your S3, it would be equals to 2 plus 5 plus 8. Your S3 is equals to 15. Now, from here, what you should be able to pick up is a new pattern that generates out of the sum. If you check here, if you can subtract your S2 from your S3, what are you going to get? You're going to get 15 minus 7. And if you subtract 7 from 15, what is it that you are going to obtain? If you subtract 7 from 15, let's check here. This is 2 plus 5, that's 7. 2 plus 5 plus, that's 15. And then 15 subtract 7 like that. We are going to get now 8. This is the sum to 3 terms. Subtract the sum to 2 terms. It gives you one of the terms in this particular sequence. If you take the sum to 2 terms, subtract the sum to 1, the sum to 2 terms, if you add 2 terms, you're going to get 2 plus 5, that is 7. Subtract the sum to 1, that's going to be 2. And then this gives you 5. So you can see that you are able to generate the term value from the sum. So what we can actually conclude is that to get any nth term from the sum, we can use Sn subtract Sn minus 1. If I want to get the 5th term, I can take the sum of 5 terms, subtract the sum of 4 terms. Then that gives me T2, T3 like that. So if I want T4, I can take sum of 4 minus sum of 3. So that's very, very important that we generate that particular conjecture from the sum. So if you are given the sum to n terms, that's what you can do. So they want T6 here, which means that T6 would be given by S6 minus S5. It is the sum of the n number of terms minus the sum of the preceding terms. So it would always be S5 minus S4, S6 minus S5. Just like that. It's a conjecture that one can use. So now sum to 6 terms, we can actually substitute on n. Where we see n, we can put 4 into 6 squared plus 1. Subtract S5, that would be 4 into 5 squared plus 1. Now, this T6, if you take your calculator and you put everything in your calculator there, you're going to get that T6 is equals to 44. T6 would be 44. Right, moving right along. For which values of x will the following series converge? For which values of x will the series converge? Now, if you look at this series, you can see that to move from the first term to the second term, they just multiplied by 4x minus 3. And you are told that it converges. Obviously, a sequence that converges is a sequence that is geometric. The arithmetic series cannot converge. It's only a geometric series that converges. Arithmetic series would always diverge. So now, we are going to be looking we are actually going to try to determine the value of r. We can use T3 over T2, which is the same as T2 over T1. Obviously, here you can see that r is 4x minus 3 because that's what they are multiplying each term with to move to the next term. So they're asking you for which values of x will this converge. Remember, from the formula sheet, you are given the condition for convergence that the constant ratio should be between -1 and 1. So if r is trapped between 1 and 1, we know what r is. That's 4x minus 3 is trapped between -1 and 1. Now, if you simplify this, you can actually add 3 across 4x minus 3 plus 3 less than 1 plus 3. So you add 3 across, you get that this is 4x is trapped between 2 and 4. So if we divide by 4 uniformly throughout, we get that x would be trapped between half and 1. We get that x would be trapped between half and 1. So these are the values of x for which the series would then converge. Right. Hopefully we are still together. This is the paper that you wrote. You can see this is how you were supposed to attempt these questions. Right. Moving right along, there is one on the sigma notation, the summation. Obviously, here they just want us to calculate, and we can see that we started 3 to 5. So the number of terms here would be 5 minus 3 plus 1 here. So we can see that we have 5 minus 3, which is 2 plus 1. These are just 3 terms. N is equals to 3. We have 3 terms. So we can just expand this and add them manually because we don't have a lot of terms there to do. So it won't be a tedious task to expand this manually. So the expansion thereof, k starts from 3 to 5, and then we are expanding -1 to the exponent of k times 2 over k. So this would be -1. K starts from 3. So this would be times 2 over 3. This is the first term. Plus you do the same -1. And this would be, now k moves to 4 times 2 over 4. Plus this would be -1 to the exponent of 5 now times 2 over 5. So that is how you generally going to expand that. Now, when you put everything there inside of your calculator, you'll get that this is -2 over 3 when you simplify, plus this would be half, plus the last one should be -2 over 5. So when you add all of them using your calculators, you'd get -17 over 30. So that would be the sum to those 3 terms. Right. We've done 2 questions, both on sequences. We've worked with arithmetic, we've worked with some geometric, and we've also worked with some sigma notation. So for now, we're just going to take a 2-minute break just to breathe. Take just that short break, and then we'll come back and continue. So your 2 minutes break would start from now. Welcome back, you guys. Hopefully you enjoyed the 2 minutes breather. Remember, we are also available on WhatsApp for the duration of this lesson. You can actually interact with us on 064 I think it's popping down on your screen there. 064 Interact with us, ask us questions. Just for the duration of this lesson, would be there to try and respond to the questions that you have based on the lesson that we are currently conducting here. Right, we move on. The next selected question here would be a question on functions. It was question 5 on your paper. You are given a parabolic function, a quadratic function. Now, what you can note here is that you are given this as fractions. That is number one. It's given as fractions. That is number one. And number two, it is given in turning point form. It is given in turning point form, x plus p squared plus q. Remember, do not isolate the turning point form away from parabolic functions, because that's the mistake that you normally make. This can be given in any form, even this form, ax squared plus bx plus c, but you guys normally favor this particular form there. It does not mean that you should always operate on that form. You should be able to move in between the forms. Remember, it's just the completion of the square. It's just completion of the square, which you should be conversant with. You should be conversant with, because you do it in grade 11, as well as you do it also in grade 12 when you do your circles in analytical geometry. So it's very, very important that you understand both the forms, so that when they examine you on a different form, you can be able to actually answer questions there. Because some of you did not even attempt this because of the form that it was given, and also because of the fact that there are fractions there. Remember, fractions are just small numbers. You cannot be intimidated by small numbers. Please make sure that you actually get comfortable working with fractions. And you have your friend here, which is your calculators, which can also assist or help you to actually navigate between these fractions. Please make sure that you familiarize yourself with working with fractions, because at this level you should be able to work with any of the numbers that are given to you. Right, now the graphs of f of x and g of x are given. The graph of f and g intersect at D and B. So from this, you know, when they talk intersection, then you are looking at f of x is equals to g of x. That is where the graphs share a common point. So it's important. Now, let's check what the questions want. Write down the coordinates of E, the turning point of f. Some of you converted the turning point form to ax squared plus bx plus c, and then they used minus b over 2a to find the axis of symmetry, back substituted to find the value of y. This was a long way around, and you were not supposed to do that, because it was based on the marks of this question. The turning point is actually, it can actually be obtained from looking at that particular equation. So you can see that in the equation, x minus 7 over 2 is equals to 0. So x is equals to 7 over 2. That is your axis of symmetry. By just taking this and equating it to 0, and then y would be equals to that, because that's it. It is the form that this takes. It takes that form. So you'd have that y is 81 over 4. So the coordinates of your turning point would therefore be, E would have an abscissa of 7 over 2 and an ordinate of 81 over 4. Right, that would be your 5.1. 5.2, determine the average gradient of f between x is equals to 1 and x is equals to 5. So what we're basically going to do here to find the average gradient, we will find f of, because it's between 1 and 5. So we're going to substitute 1 on the parabolic equation, and then substitute 5 on the parabolic equation to get the corresponding values of y. So we're going to put in our f of 1. If you put f of 1, which means that where you see x, you're going to put 1 minus 7 over 2 squared plus 81 over 4. So if you do that, if you substitute 1, obviously you're going to get 14. And then f of 5, what you're going to do is you'll substitute 5 where you see x. So this is 5 minus 7 over 2 squared plus 81 over 4. This, if you put it in your calculator, it will give you 18. So you now have f of 1 and f of 5, which means that you can be able to get the gradient of between x is equals to 1 and x is equals to 5, like that. So you'd be able to find that average gradient, which would be equals to actually f of, can use f of 5 minus f of 1 over 5 minus 1. So this would be 18 minus 14 over 5 minus 1. So the gradient will therefore simplify to the value 1. So that's how you work out that average gradient. Remember, it's like you were finding those points. F of 1, if x is equals to 1, y would be 14, and if x is equals to 5, y would be 18. So you are using these 2 points to find the gradient, just your normal gradient that you are used to. Right. Moving on, calculate the value of A, the x coordinate of point D. Calculate the value of A, the x coordinate of point D. Now, in order for you to calculate that value of A, you can see that point D represents the point of intersection as well as point B, which means that you now need to equate the two functions because it's a point of intersection, which means we can now write this in the form y is equals to ax squared plus bx plus c. So if we do that, we're going to work out that this would be we can use it as f of x. It will simplify to, if you what you call expand this and work it out like that, x minus 7 over 2 into x minus 7 over 2 and then plus 81 over 4. This would work out to negative x squared plus 7x plus 8. It will work out to negative x squared plus 7x plus 8. Then now you can equate f of x to g of x. So now we have that this is minus x squared plus 7x plus 8 is equals to minus 3x plus 24. Remember, you are equating them because at the point of intersection, the graphs have the same y value and the same x value. So you equating the y values so that you find the x values. So now when you simplify this, you get that this is minus x squared plus 7x plus 8 plus 3x minus 24 is equals to 0. If you want to write this in standard form, this would be minus x squared and then plus 10x, and then this should be minus 16 is equals to 0. So this is x squared minus 10x plus 16 is equals to 0. We can continue with our work here. So now we just need to actually find our factors. So this would be x equals to 0. The factors of 16, which can give us 6, that should be 8 and 2. 8 and 2 like that, and both of them should be negative like that. So x is equals to 8 or x is equals to 2. So you can see that at D x is equals to 2 and at B x is equals to 8, because the x value at D is less than the x value at B. So which means the bigger one belongs to point B there. Therefore, the value of A, remember they said calculate the value of A, the x coordinate of point D. The value of A is equals to 2. So we've worked out that the value of A is equals to 2, like that. Right. Hopefully we are still together. We move on. Point S is a point on the graph of F where X is trapped between A and 8, which means that our X is trapped between 2 and 8. It's greater or equals to 2 and less than or equals to 8. So they say line ST is drawn parallel to the y-axis with point T on the graph of G. Determine ST in terms of X. We are looking for this vertical distance ST in terms of X. And we know for our vertical distance, the X value there remains the same. It is only the Y value that is changing. So to find that Y value, ST is a vertical distance. To find the vertical distance, you always take Y top minus Y bottom. So our Y top, obviously we've worked out this expression for f of x. So our Y top here is at point S. Y at point S. Y at point S is the Y value of a parabolic function, which is f of x, and Y at point T is the Y value of a linear function, which is g of x. So we've simplified our f of x as negative x squared plus 7x plus 8. That's how we simplified it on the previous slide when we multiplied this out and wrote it in the form of ax squared plus bx plus c. Now we are subtracting here negative 3x plus 24. Now if we do that, it would be negative x squared plus 7x plus minus negative 3. This would be plus 10x, and then plus 8 minus 24, plus 8 minus 24, this should give you negative 16. That is just 8 minus 24, like that. It should give you negative 16. So this is the value of ST in terms of x. It's minus x squared plus 10x minus 16. Negative x squared plus 10x minus 16. That would be the value of ST in terms of x, because that's what they said they wanted here. They wanted ST in terms of x, the vertical distance ST in terms of x. Right, now moving along, they say calculate the maximum length of ST. Remember, we just simplified and worked out that ST is minus x squared plus 10x minus 16. That's what we just worked out right now. So now we need the maximum value of this. Remember, it's a quadratic function. You can complete a square. You can to find the maximum, you can do it just like the way we did our quadratic to find the maximum of that quadratic pattern. You can complete a square. You can use calculus where the maximum occurs when the derivative is equals to 0, or you can use minus b over 2a. So I just use calculus here. dst dx would be minus 2x plus 10. And then remember, max occurs when dst dx is equals to 0. There's a reason why they are saying maximum, because if you look at this equation, it represents a parabola with an a value of minus 1, which means a is negative. It means it will be concave down, and if it's a concave down, then it has a maximum turning point. Hence here they did not say minimum, but they said maximum. So it's important to also analyze it that way. So we get that negative 2x plus 10 equals to 0. So 2x is equals to 10, and then x is equals to 5. So we got the value of x that would give us the maximum length of ST, which means now we can then move along here and get our max ST will then be, you go back to the original equation where you see x, we're going to put 5. This is 5 squared plus 10 into 5 minus 16. So this would just give you 9. So the max value of ST would be equals to 9. So we are done with our functions like that. We just completed our work on functions. So I'll just give you a 1 minute break, just 1 minute, just to process what we've been doing on functions, the conversion between the forms of the quadratic function there, ax squared plus bx plus c, as well as a into x plus p squared plus q. So just take that 1 minute just to review what we've just did, and re-look at it, reflect, and then we come back, we try to push the next few questions. Your time starts now.
I want you to ask yourself these three questions. Number one, what do I want? Do I want to become an A student, or do I want to become an average student? Number two, I want you to ask yourself, how do you plan on getting there? Are you going to put more extra hours, or are you going to just sleep? Number three, who will be with you in this journey? Because it is important that we associate ourselves with students who have the same vision as us, who want to become a student, who want to put in the extra work, who want to become better at what they do. Unsuccessful people do not plan, they just let life happen to them. But successful people are planning on how they want their lives to be. And right now, you plan on how you want your results at the end of the year to be like.
Right, hello and welcome back. I hope you were able to reflect and try to process what we actually did there, as well as look at it against what you actually wrote when you wrote your prep exam. We're just trying to show you that these questions were answerable. A lot of you struggled with a few of these questions, but you need to know that they are answerable. You need not to panic when you write your final exam. Just relax. Everything that you've practiced and that you've known, you're just going to write it there. Do not panic. Just relax and enjoy answering these maths questions, because at times you panic a lot and you end up committing unnecessary silly errors there. So we are moving on. The next question is extracted from the question on financial mathematics. We are trying to look at how you were supposed to solve these finance questions that were asked. Remember, it's finance, growth, and decay. It does not mean that they will always ask you about money. It's not always money. Finance, growth, and decay. So it can be about population. It can be about anything else. They can talk about a virus, a coronavirus outbreak, to say that these were number of people that were available. These are the people that were affected, and all of that. So you need to also make sure that you understand it from that perspective, because in grade 10 you also do population growth using these formulas as well. So it's important to note that it's not only money that you need to actually understand with finance, but you need to understand the dynamics of the use of these formulas, especially with finance that is in grade 10 and grade 11, that would be examined in grade 12. Obviously, when we talk about annuities, then would be specific that we are talking about money in grade 12. Right. Let's look at this question. A survey conducted in December 2015 determined that 5.7 million South Africans were living with HIV. The researcher used a model of exponential growth to predict that there would be 6 million people living with HIV in December 2022. Calculate as a percentage the annual rate of increase that the researcher used for the 7 years. So you see, this talks to population and virus. So it's not always money, as I just indicated. So now you are told that the formula that is used here is A is equals to P into 1 plus I to the n. This is exponential growth. Now, you are told here, it is specific that there are 6 million South Africans that would be having, the prediction says it's 6 million in future. So A is your future value in this case. If A is the future value, or the value after whatever growth has occurred. So the growth has occurred from P, the principal value, to A, the value after a certain period of time. So it's the value in future. So in this case, it's 6 million. You're told that it's predicted to be 6 million, like that. So in this question, they were also trying to test whether you know the number of zeros that should be there in 6 million. So a lot of things were tested here. So also we have 5.7 million, like that. So that would be the principal value. 1 plus I, in this case, it's what we are looking for. The growth, you are told that it occurs in 7 years. So there are no compoundings here. You are talking about real world statistics in this case. So you cannot have any compoundings unless if they're talking about money in this case. But they are talking population growth, and you are told that the rate is annual. So there are no compoundings. It's once a year. They are going to look at the growth every year, like that. So if we try to simplify this, you can see that obviously we're going to have that our 6 million divided by 5.7 million, like that, would be 1 plus I to the exponent of 7. So if we want our I in this case, we are going to be taking the 7th root of 6 million over 5.7 million. That would be our 7th root thereof. And from here, we can obviously subtract 1, like that. So we get that if we put that in the calculator, that the fractional interest rate would be 0.00735, which means that R, remember R would be this value, you multiply that by 100. So you're going to get that this is 0.74%. Remember to move from I to R, you multiply the fractional interest rate by 100 to get the actual interest rate, like that. So remember, we are taking that from the fact that I is equals to R over 100, right? That, so if we want R, we're then going to say I multiply by 100. So that is why after getting I multiplied it by 100, like that, right? We move on. 7.2, it's the Shimi problem. Shimi invests 4 million into an account earning an interest of 6% per annum compounded monthly. She withdraws 30,000 per month. Her first withdrawal is exactly 1 month after she deposited the 4 million. You see, this now they are talking about the money that Shimi invests, and then Shimi is going to then withdraw that money. That's very, very important. One might think that this is a future value annuity, and it's not. One might think it's a future value because it speaks to investment. It speaks to investment because they say invest. So if one looks for these one looks for these keywords, one might see invest and think that, oh, it's a future value annuity because they are talking investment. But now if you zoom into the problem, you are told that she withdraws 30,000 per month. So this is like a reverse. This is like a reverse loan, where now Shimi, the money that Shimi invested is going to be the money that Shimi borrows to the bank, and then the bank is going to pay back Shimi that money with interest. So this now becomes what? A present value annuity. It becomes a present value annuity. It's very, very important that you try to pick up. When you make an investment and you withdraw money from that account for a specific time period, then that becomes your a loan that you offered to the bank. We treat it as a loan that you offered to the bank, and the bank is paying you back with interest. Just like when you go to a bank and borrow money and pay the bank with interest. Now it's like the bank borrowed money from you and it's paying you back that money with interest. So it's still a loan. So we're going to use the present value annuity formula. So how many withdrawals can Shimi make? So we want to know how many withdrawals of 30,000 that Shimi can make. So we are using PV, that is the present value. It's X into 1 minus 1 plus I to the negative N over I, like that. So that is the formula that we are using. So the present value, the loan amount that Shimi gave to the bank, it's 4 million. This is equals to the monthly withdrawals. The annuity is 30,000 into 1 minus 1 plus 0.06 over, if you check here, it's compounded monthly, so we divide by 12. Those are the compounding periods, and we want to calculate the value of n. The fractional interest rate 0.06 divided by 12. So out of that, obviously we've generated an equation, so we need to solve. So we're going to have that this is 4 million times 0.06 over 12, like that. We divide that by 30,000. This would be equals to 1 plus, or rather it would be 1 minus 1 plus 0.06 divided by 12 raised to negative n, like that. So what we can do here, we can simplify. If we simplify that further, we can get that this is a third. This is a third. 1 over 3 is equals to, we transposed the one, we simplified this expression, and we transposed the 1, like that. So we get that this is, let me write it here, a third is equals to, this would be 1 plus 0, 0.06 over 12 raised negative n. We can continue with it here. So when we continue with that, we convert that to log form. Obviously, this would be the log. The number is a third. The base would be 1 plus 0, 0.06 divided by 12. So that's how we convert that to logarithmic form. Therefore, if you are to attach that on your calculator, if you use your calculator to put all of that, you're going to get that n is equals to 220.27. So you have that it's 220. If you check, they said how many withdrawals of 3,000 or 30,000. Remember, Shimi would withdraw how many times? 221 times. But out of the 221 times, it's only 220 amounts equals to 30,000. The other amount, it will be a fraction of 30,000. So therefore, if the question was how many withdrawals can be made, you would say 221 withdrawals. But the question is how many withdrawals of 30,000. So they are specific how many withdrawals of the annuity amount. So this 220.27, the 220 represent the withdrawals of your annuity amount, and then this the fraction 27 and so on represents a certain portion that would also be withdrawn on the 221st withdrawal. It would be an amount that is less than 30,000. That is why it's given by just that small fraction there. So how many withdrawals of 30,000? It would be 220 withdrawals of 30,000. Remember what I said? I said if the question was how many withdrawals will Shimi be able to make? How many withdrawals? They did not specify the annuity amount. It was going to be 221 withdrawals. But here they are specific. How many withdrawals of 30,000? And you get 220.27. You have 220 withdrawals of 30,000 and a smaller fraction of the amount that would be withdrawn after the 220 amounts of 30,000 have been withdrawn. So that's very, very important. These numbers, they speak volumes here. Right, we move on. Now, it's another question here, 7.2.2. If you check 7.2, if you check here, 7.2, I put the question exactly as it is so that we can be able to access the data. But now the question that we are answering is 7.2.2, which says how many withdrawals will Shimi be able to make if she changes the amount withdrawn per month to 20,000. So she is no longer withdrawing 30,000. She is now withdrawing 20,000. We want to know how many withdrawals will Shimi make. So let's make a calculation like that. Remember, it's the present value annuity formula. So the present value of the loan is 4 million. This is equals to the withdrawals now change to 20,000 into 1 minus 1 plus the fractional interest rate is still the same, like that, over, and then this becomes 0.06 over 12, like that. So that's how we can actually be able to work this out. Now, if we work this out, we're going to get that this is 4 million to 3 times 0.06 over 12 over 20,000, like that. And this would be equals to 1 minus 1 plus 0.06 over 12 to the negative n. If you simplify this, you get that, you'll simplify this, you'll get that this is 1 plus 0.06 over 12 to the negative n is equals to 0. That's what you are going to get there. It would be equals to 0. When you simplify this on the right hand side, and then on the left hand side, and then you transpose the 1 like that, you're going to get that this would be equals to 0, because you get this is equals to 1. So now this means that Shimi would be able to actually she can withdraw this money infinitely many times. She can withdraw the money infinite times. She will never run out of the money. It's like we are saying she will have she can make any number of withdrawals. She can make any number of withdrawals. Why is that? It is because the interest that accumulates here would exactly be equals to the money that she withdraws. The interest would be equals to the withdrawn amount. That is why we're saying she can make infinitely many withdrawals. Alternatively, you can solve this question by actually trying to work out using A is equals to P into 1 plus I to the n. By trying to work out, after adding interest, how much amount is there, you'll get that this would be given by 4,020,000. So every time she would invest, she invested 4 million, and that 4 million, according to the calculation, would give you every month would give you an interest of 20,000, and she withdraws 20,000. So the following month it gains an interest of 20,000. She withdraws 20,000. The following month, and so on and so on. So you get to see that the money that she withdraws is only the interest. So the 4 million that she actually invested is not going to be touched, because she's only withdrawing interest. So she can withdraw infinitely many times, because she is not actually tampering with the money that she invested. She's only taking out the interest out of that money. So for interest sake, I would want you to use this alternative form. In this alternative form, you are going to calculate A, the accumulated amount, if 4 million is invested at that percentage. You will get that it would be exactly equals to 4,020,000, and she's withdrawing 20,000, which means that she's not touching the original investment. So the number of withdrawals that she can make are infinite. Right. Moving right along, Astrid opened a savings account with a single deposit of 1,000 rand on 1 April 2022. She makes 18 monthly deposits of 700 at the end of every month. Her first payment is made on the 30th of April, and her last payment is made on the 30th of September. So you can see that they are generating annuity here. But there's a problem here. The first amount is bigger than the 700 that is invested every month. So it shows you that you now have compound interest as well as future value annuity combined, which means there are many ways that one can solve this problem. We will discuss those ways here, but we'll only solve using one of the ways. So if we draw a timeline, remember, good people, when solving finance questions, it's very important to draw a timeline. You need to simplify your life, make your life easy by drawing a timeline which provides a visual representation of actually what is happening in this particular problem. So it provides you with a visual type of a scenario or a picture of what is happening, so it becomes easy for you to put pieces together to be able to solve that question. So now you can see that a single deposit is made on the 1st of April. So we can say that we are making a deposit of 1,000 at T0, and then from there she makes 18 monthly deposits of 700 at the end of every month. So you can see at T1 700, T2 700 until T18 700. Remember, these formulas work to the last payment. If you are using a future value annuity formula, it works to the last payment. Or they normally say the last amount does not gain interest, or the last amount that is invested does not gain interest. That is the condition to which you must use this formula. Now, out of this, obviously, we know T17 is also 700. Now, I'll explain one of the ways in which you can solve this. One of the ways would be what I'm going to use here. I'll take this 1000 because it's not part of the annuity. I'll grow it using compound interest until the end of the investment period. That is a T18 using compound interest. So it grows using compound interest. Remember, the interest rate here is 15% per annum, right? The interest rate is 15% per annum, compounded monthly, like that. So if it's 15% per annum compounded monthly, then you get to see that this money is going to grow for 18 months. So you can use compound interest to grow that money. Can use compound interest to grow that money. And then from there, I'll take these 700s because they are invested on a regular a period of time, or on equal intervals. I will then attach them to a future value annuity formula because they form an annuity. Money that is invested at regular intervals, the same amount that does not change on regular intervals, then it forms what we call an annuity. So we're going to be having an annuity of this 700. So it means that for my amount, what I can do is I can say it would be my P value plus, or I can use my A value from compound interest plus the amount that I get when I use the future value. So my A value would be from the formula P 1 plus I to the n. That's how I'm going to grow this 1000 plus these 700s here. They grow using future value annuity, which means I'll have X into 1 plus I to the n minus 1 over I, like that. So that would be the formula that I would be using there to try and work that one out. So basically what I'm going to have here is my P is 1000, 1 plus the fractional interest rate 0.15 divided by 12, 18, plus I'm making 700s. I'm having a 700 what you call a deposit that is made every month. It grows at an interest rate of 0.15 divided by 12 for I'm making 18 of those payments, minus 1 divided by 0.15 over 12, like that. So you can see that I grew this using compound interest because the amount stays there for 18 months. Remember, N here in the compound interest formula represents the duration of the investment, but N here in the future value annuity represents the number of payments that have been made. So if you simplify this further, you're going to get that this amount in your calculator like that would simplify to 15,282,91, 15,282.91 cents. So that's what you're actually going to obtain if you combine them. Now, alternatively, what you can do is you can break down the 1000 into 700 and 300. So you'll take this 300 and grow it with compound interest. And you'll take this 700 and say now it would be part of the future value annuity, which means one more payment of 700 would be made. So that's an alternative way in which you can solve this. I'll repeat, you break this 1000 into 700 and 300. The aim is to try to get, because in this 1000 there is also 700 there, which can be put as part of annuity. So if there's a 700 deposit that is made at T0, it means there's one extra payment, which means that for this future value formula, instead of using 18, you'll be using 19. And then for this 1000 here, instead of using 1000, you'd be using 300. So that's an alternative method that one can actually use. Right, so that is how you are supposed to solve the finance questions. Now I'm left with a few questions on calculus. So because of time, I'm not going to do all of them. I'm just going to do 2 questions which I think were very, very critical. So this I am going to leave out. It's using the definition first principles. Please go back to your first principles. Most of you did not perform very, very well on this because of the mistakes, the minor mistakes that you've made on notation and all of that. Please go back and fix that. Now also rules of differentiation. I'm not going to do this question here because of time, but I am going to touch on this. Given f of x is 3x cubed minus 3x squared plus 6x minus 2. This was question 8.3. They say determine the interval for which f is concave up. Determine the interval for which f is concave up. Now, first thing that we do when we look at concavity is we should be looking at the second derivative. It is always concave up, concave up like that when f double prime of x is positive, and it's concave down when f double prime of x is negative. So here the question was determine the interval for which f is concave up. So we need to first find the first derivative, which is 9x squared minus 6x plus 6. And then from there, we find the second derivative, f double prime of x. This would be 18x minus 6. Obviously, we know the condition for concave up. F double prime of x, that is the condition for something to be concave up. F double prime of x should be positive, which means 18x minus 6 should be greater than 0. 18x is greater than 6. And then if you divide both sides by 18 like that, you get x is greater than 6 over 18 would give you a third. So this would be your interval for which this particular function, it's a cubic function. You see the highest degree is 3 there. You have a 3 there. That's the highest degree of that. So it's concave up for this particular interval. So that's very, very important to note as well. Right. Now we're going to look at the last question. The last question which I'm going to cover for this lesson would be a question on optimization that you were actually given on your exam paper. It's a question on optimization, and I want us to zoom into that question. Now, it was it reads as follows: the profit W of X earned by a company to manufacture X bicycles per week is given by. So you are given the objective function, which means that this would now be a direct application. It's a direct application. The application to calculus can be direct or indirect. If it's direct, you are given the objective function, then you optimize. If it's indirect, then you are the one responsible for formulating that objective function. So in this case, we are given the objective function and we want to determine the weekly bicycle production to maximize profit. So they want to know how many bicycles must you produce so that the profit is maximized. Now, you can see here that this is a cubic function with a negative value of a. So you can see that this cubic function should have a shape like that. It should have a shape like that because of that negative. Right, let's look at this. They want us to maximize. So we need to find the value of x for which the maximum occurs. So first things first, we are going to find the derivative of that. We get that this is negative 3x squared over 150 plus 6x minus 250. We know max occurs when the derivative w of x is equals to 0. So now if you equate this to 0, you're going to get that this is minus x squared over 50 plus 6x minus 250 is equals to 0. That's how you simplify it. Now if you multiply throughout by 50, because 50 is your LCD there, so you get that this is, remember we want to write this in standard form. This is minus x squared. 6 times 250 would give you 300x. And then 50 times 250 times 50, it will give you 12,500. This is equals to 0. So remember, we want to write it in standard form. So divide by negative 1. So it's x squared minus 300x plus 12,500 is equals to 0. So if we continue with it here, we can actually find those factors using inspection. X, the factors of 12,500, that can give us 300. Remember, you can use your quadratic formula here, but you can also work out the factors using inspection. You would get that it's 250 and 50. And obviously, the bigger one should be positive, and then you have that the smaller one is negative like that. Let me just confirm that. Let's see, negative. Oh, I made a mistake here. If I divide by negative, it should be negative x squared. It should be x squared minus 300x plus 12,500 like that is equals to 0. So I made just a small error there when it came to dividing by negative 1. So it's x squared minus 300x plus 12,500, which means the factors are going to change to x minus 250, because the last term is positive. Both of them should be positive like that. So I'll get that x is 250, or x is equals to 50. So you're getting two x values. Remember, these x values, if this is a cubic function, then they represent the minimum and a maximum. So now we want to find out which one is the maximum. There are many ways that you can use. You can use what we normally refer to as the first derivative test, where you're going to put these stationary points and test the gradient of the function on the left and on the right of each stationary point, so that you get to see which one is the maximum, which one is the minimum. Or you can use the second derivative test. The second derivative test is the one that we use for concavity. You check f double prime of x. If it's positive, then for that stationary point, it would be concave up. If it's negative, it would be concave down. Alternatively, remember I said you can use the first derivative test, you can use the second derivative test, or you can take both of these points and substitute them back into the original equation. If you substitute them back into the original equation, the answer that's going to give you a bigger number is the one that is a maximum. So if we are to use the third method, remember I said first derivative test, second derivative test, or back substitution. I am going to actually use the third one, back substitution. If you substitute this back on w of 250, where you see w, you're going to put 250. When you do that substitution, you're going to get 18133,33. If you substitute 50, you're going to get negative 85 633, like that. So now you're going to take the bigger value. You can see that this one gives you a bigger value. So it's the one that gives you a maximum. So you're going to say, therefore, 250 bicycles, 250 bicycles should be produced. 250 bicycles should be produced. Remember what I just said. After finding the two values, if you want to know which one is the maximum, which one is the minimum, you can use the first derivative test. With the first derivative test, we are going to test both these stationary points. You check the behavior of the gradient on the left hand side of the first stationary point and on the right hand side, just close to that stationary point. You do the same with the other stationary point. So it will give an indication of whether it's maximum or minimum. Or you can use the second derivative test, which is a test for concavity. You're going to check f double prime of a specific stationary point. If it's positive, then it will be concave up, which means that it's giving you a minimum. If it's negative, it will be concave down, which means it's giving you a maximum. Or alternatively, you can use back substitution. With back substitution, the bigger answer gives you the maximum value. Then you can be able to make an informed decision on that, or an informed choice as to which answer to choose from the two answers. But it was important for you to try to actually show steps of how you've concluded which one is bigger. That is why the question was for 8 marks. Right. Good people, I think we tried our best to can actually cover as much questions as possible on your prep exam paper 1. Remember, the questions that we did not do, you take responsibility. You go back to your teachers, you check with them on those questions, you check on how they were supposed to be attempted, and you try to check how you can actually improve the mistakes that you've made so that you don't commit the same mistakes when you write your final exam. Remember, you need to practice, and make sure that you understand what is it that you are expected to understand. Make sure that you reach those targets. Make sure that you practice every time. Right, for now, it's thank you very much. All of the best. Take care of yourselves, take care of each other, and make sure that you practice mathematics to pass. Bye-bye.